All right, so this is your Unit 5 study guide. For number 1, we're going to use these two functions right here. You will need your scratch sheet of paper for these ones because unless you write super tiny, it's not going to fit. All right, so for letter A, and we'll see how much of this comes back to you. Obviously, I'm going to tell you all of the answers, okay? But I'm going to question you too, so it's not like I'm just lecturing at you. G of f of 8, which function are we going to plug into first? Good, function f, you start with the inside one. So you're going to do f of 8, and whatever you get, you'll pass it along to function g. So it's like the telephone game. So you're going to do f of 8, whatever you get, it's going to get plugged into function g. All right, so let's do f of 8 right here. 8 squared, 64, minus 8 times 3, 24. So 64 minus 24 would be 40. So we're going to do g of 40. Should you write that step? Yeah, because if your final answer is wrong, I can't do partial credit if you didn't write it out for me. So g of 40. Now we're going to plug in 40 right here. Negative 4 times 40, that would be negative 160 plus 5 would be negative 155 as your final answer. So you plug into the inside function, whatever you get, plug into the outside. B and C, you're not dealing with an actual value, it's just a variable. So you're going to take all of g of x, plug it into function f. So this entire thing is getting plugged in over here. You have to plug it in to both variables. So everywhere there's a variable, you have to plug in that negative 4x plus 5. All right, so the first part, it would be negative 4x plus 5 squared. Don't write squared, just write it twice. Do you remember us having that conversation? Like squared means you want to write it twice, right? So it will be negative 4x plus 5 times itself, that's what squared means, minus 3 times negative 4x plus 5. Again, you're plugging that in to both variables. And then this is a lot of tedious distributing, okay? But can you multiply numbers together? Yes, you can. I believe in you. Go team. You can do it. Just going to multiply this all together. So this first part's FOIL. The first, negative 4x times negative 4x. That would be what? Perfect. 16x squared. Nice. And it'll be positive. The outsides will give you negative 20x. The insides will give you negative 20x. So together will be negative 40x. And then the last 5 times 5, 25. And then for this part, we're distributing not a 3, but a negative 3. So just make sure you bring the negative with it. It will be plus 12x minus 15. That's the hardest step, distributing all that together. But again, if you stay calm, remember you know how to multiply. The hardest thing is the negatives, right? And then it's like terms. So we'll have 16x squared. And then the x's will combine. Negative 40x plus 12x. That will be negative 28x. And then 25 minus 15 is 10. You do not need to factor. There's nothing else to combine. Once you do the like terms, you're done. Please just stop. Now, when you do g of f, this time f gets plugged into g. This one's going to be a whole lot easier. Let me erase all my arrows and I'll draw in the new arrow for you. That means this entire thing is getting plugged in over here. So we're going to have negative 4 times all of this plus 5. And there's only one step to that. What's the only thing you're going to have to do? Yeah, distribute the negative 4. So that'll be negative 4x squared plus 12x plus 5. Again, once you get there, don't do anything else. There's no need to factor or anything to stop. Leave it. Please put the phones away. And if I can see your nose, I shouldn't. All right, here, we're just going to use these graphs. These ones will fit on the paper. These are kind of like barely any work problems because you're going to just use these graphs to answer the question. Letter A, f of g of 0. It's just like letter A up here. You're going to start with the inside function, and whatever you get, plug it into the outside function. So let's start with g of 0. Here's g of x. It's the absolute value one. We want to plug in 0. That means we're looking. Oh, really? All right, so we're going to start with g of 0. Whatever we get, we're going to plug it into function f. So here is g. It's the absolute value graph. When you do g of 0, you're just looking for the point that is 0, comma something. So on g, you would get the point 0, comma what? 2. So you're going to then plug 2 into function f. And so we're going to go to function f. That's the quadratic one. We're going to plug in 2. So you want the point 2, comma something, and then that something is your final answer. So it would be 2 what? Negative 2. Good. So there's actually like no math. You're just pointing to the graph and finding the points. Let's try another one. We're going to do g of negative 1, and whatever we get, we're going to plug it back into function g again. All right. So what is g of negative 1? 0. Yeah, and there's no work. It's kind of like you just look at it and go, oh, it's 0. So now we're going to do g of 0, which would be 2. So your final answer to the whole thing is 2. Again, write this middle step, though, because if your final answer is wrong and you don't have anything written there, then I can't do partial credit. All right, which function do we start with for this one? Good. F of 4. Whatever we get, we'll plug it into function g. All right, so look at function f. What is f of 4 going to give us? 2, right there. And so we're going to do g of 2, and g of 2 is 6. So 6 is your final answer. For number 3, it is the exact same thing, except you're using the table, which is actually even easier because you don't have to even read a graph. Like the table literally gives you the answer. For this one, f of g of 4, you're going to start with g of 4. Whatever you get, plug it into function f. All right, so what is g of 4? It's really just, can you read a table? Match up the g of x and the 4. What do you get? 3. So plug that into function f. It's f of 3. And then what does f of 3 give you? Yep, negative 2 is your answer. All right, and then for b, you're going to do f of 1. Whatever you get, plug it into function g. So f of 1 is 3. And then g of 3 is 0. All right, for number 4, you're separating the function into the outside and the inside. F is going to be the outside, g is going to be the inside. I think it's easier to do g first. It's the guts of the problem, right? So what is the inside stuff here? Don't overthink it, just what's inside. Yeah, good, the x cubed plus 10. So that's the inside stuff. And which function like got hungry and ate that stuff? Like you plugged this into what? Good, 5th root of x. So if you do f of g, you get this. We're just separating it. So for this one, again, let's do g first. What's the insides, like the guts of it? Get that 5x plus 1, good. And that got plugged into 8 over x. There are a couple other ways you can separate those. Anything you write that's correct, I'm going to give you credit for, obviously. I think this is the easiest way to do it. All right, here's your domains and, I was going to say domains and ranges, but we're not doing range, just domain. Let's do all the domains of these functions first, because I think once you get those filled in, it calms you down. It's like, hey, I answered a lot of it. All right, who is not invited to the domain party for this one? Who's getting kicked out? 6. Leave out 6. 6 is causing problems. All right, this one moved left 1. If you want a visual, you don't have to draw this, but if you want a visual, it would look like that. So it would be -1 to infinity, and -1 is going to get a bracket because there's actually a point. So what about this one? It's really similar to the one we just did. This would be bracket and then what? Good, it went left 3, so -3 to infinity. And then g, since that's squared, it would be a parabola. What's your domain for any parabola? All real, so you get everything, which is nice. And so for number 7, f of x, X squared, that's a parabola. That's going to be everything. We love those are gimme answers, right? Those are nice. And then this one went right 8. So it would be 8 to infinity, which I'm sorry, I know that looks weird because it's the 8 to the infinity, but you'll be okay. All right, so now let's do the composites. I made them all f of g. G is getting plugged into f for all of them. All right, so here, square root of x plus 1 gets plugged in for x right there. It's going to be 1 over square root of x plus 1 minus 6. All right, these do not combine, so just leave them alone. All right, so domain, you're going to start with the inside function. Does G have a restriction? You are stuck with it. Do you guys remember this? All right, inside one, you're stuck with it. Does F have a restriction? Hey, G of X, you better not equal 6 or else. All right, so on your scratch paper, or if you write really tiny, I guess you could fit it off to the side here if you write really small. I'm going to write it on my scratch sheet so that you guys can see it. We're going to say, hey, G of X, this whole function, you're going to say you better not equal 6. Better not see you hanging out with number 6. Trouble. And then you solve that. So to get rid of the square root, what would you do? Square it. So 6 squared, 36. And then subtract 1, you get 35. So X is not allowed to be 35. Humor me for just a second, okay? Watch what happens when you plug in 35. 35 plus 1. Square root of 36 minus 6. Right? So we're going to leave out 35, but remember, you're also stuck with this. So you have to begin with the -1. So it's going to be -1 to infinity, but leave out 35. Because whatever that inside function's domain restriction is, you're stuck with that too. All right, so number 6, G gets plugged into F. So this x squared minus 7 is getting plugged in over here. So you're going to have this big old square root, and underneath of it, you would have x squared minus 7 plus 3. The only thing you can do there is combine the -7 and the +3, and you would get -4. So x squared minus 4. Again, don't cancel any of that out. Just leave it alone. Hands off. All right, does G have a restriction? No. Great. Does F have a restriction? Hey, G of X, you better stay bigger than -3 or else. All right, so I'm going to set up a side problem. Again, if you write really small, you might be able to fit it in the margin there. I don't want to try and squeeze it in. So we're going to say, hey, G of X, this x squared minus 7, you better stay bigger than -3. Okay, what would you do to start solving this? You would add over the 7. So -3 plus 7 would give you 4. And then to get rid of the squared, you're going to square root. Now, whenever you square root, you need to do plus and minus. And whenever you do the -1, what are you going to do to your little inequality? Flip it around. So we want x bigger than 2 and smaller than -2. If you recall, okay, I'll write it on here so it'll show up on the video. These are those ones, you don't have to draw this, I'm just showing you because I think these graphs are cute. These are the ones that look like this, like a little alien antenna. Do you remember that, sort of? I know, it was like a month ago. All right, anyway, it's going to be -infinity to -2 with a bracket, union 2 to infinity. All right, and then last one, G gets plugged into F. So this square root of x minus 8 is getting plugged in over here. Now this one is going to have a little bit of simplification to it. So I'm going to write this like in the margin here so I can simplify it down. The squared and the square root will cancel in this case because you're squaring the entire square root. So those are going to cancel out. You'll just have x minus 8, and then you can distribute and combine like terms. So if you distribute the 1/2, what is that going to give you? Good, 1/2 x minus, good, half of 8 would give you 4. and then minus 5, so it'll be 1/2 x minus 9. So again, you squared the entire square root, so that was able to cancel. All right, does G have a restriction? You are stuck with it. Does F have a restriction? No, that means you don't have to do a side problem. This is just your answer. That's the easiest version. If the outside function has some kind of rule to it, that's where you have to do a side problem and work it out. But otherwise, you just keep what's there. All right, number 8, we're gonna just do A. I'll leave B for you if you feel like doing that one and checking your answer. It's on Schoology. All right, you're going to find the whenever I give this test, someone always comes up to me and asks me, what's a composition? And I'm like, I can't tell you, that's what I'm testing you on. Composition, it's f of g and g of f. That's what a composite function is. All right, plug one function into the other. So you're going to show that they are inverses using composition. You're showing that everything cancels out. So first we're going to find f of g, then we'll find g of f. Yes, everything's going to cancel, but you have to show me what order it happens in. So you're going to have to show me the order of the steps. All right. So plugging g into f, this entire cube root is going to get plugged in over here. So that's going to be 2 times this entire function cubed and then minus 9. And yes, it's all going to cancel, but you have to show me what order it happens in. That's what I'm testing you on. So what cancels first? Good, the cubed and the cube root are going to cancel first. So you have to write out what it looks like without those, because I can't see what order it canceled unless you write that. You'll be okay. All right, what cancels next? The 2's. So those cancel. You have x plus 9 minus 9, and then the 9's cancel, and you just get x. And then we're going to do g of f. Again, everything's going to cancel, but what's important is the order. So you have to show me what order. So now we're going to plug f into g. So this entire thing is getting plugged in over here. Can you stop that and write this down? This is going to get plugged in over here. So you're going to have a gigantic cube root. And underneath of it, you're going to have this whole function plus 9 over 2. Spoiler alert, it's all going to cancel in the exact opposite order. Does that make sense? Like it's going to do it backwards to what we just did. What's going to go away first in this case? Yep, the 9's are going to cancel first. So show that you have everything else still there. And then what? The 2's. And then the cubed and the cube root. So it's like I'm telling you the answer, like, yeah, they are functions and it's all going to cancel. You should just end up with x, but I'm asking you to show me the order of the steps. Part B is just another practice problem of that. Again, I'll leave that for you if you feel like doing that one. The answer's on Schoology, you can check it. All right, we'll do 9 and then I'll give you guys a little break. All right, so number 9, find the inverse and then graph both the functions on the same coordinate plane. I think it's best to do the graph first. So that is what I'm going to do. No, there will be a grid on your test. Anytime I ask you to draw a graph, I'll give you a grid. I'm going to color code mine. You can if you want. If not, that's cool too. Whatever. We're going to graph that first. What is the easiest number to plug in? I'll make a little chart for us here. I would plug in 0. 0 is the easiest number to plug in. All right, let's see what we get. 0 to the 5th. 0 times 0 times 0 times 0 times 0. 0, good. Times 5, 0, good. Plus 6 is 6. Divided by 2 is 3. So we get 0, 3. I need a couple more numbers though. What else do you want to plug in? 1. That'd be the next easiest number. 1 to the 5th. 1 times 1 times 1 times 1 times 1. 1 times 5, 5, plus 6 is 11. 11 divided in half. 5.5, perfect. So we get 1, 5.5. And I would like one more point. Let's do at least 3 points. What else do you want to plug in? Let's do -1. -1 to the 5th, that would be -1 times 5 would be -5 plus 6, 1 divided by 2 is 1/2, 0.5, however you want to write that. So -1 and then 1/2. And when you connect them, just make sure that you make it wiggle. It's a polynomial graph. It looks like a cubic graph, just kind of like stretched out a little bit. Now, when you do the inverse graph, all you have to do is take those points and do what? Flip them. That's it. You can graph the inverse without even finding the inverse. Just take these points and reverse them. Instead of 0, 3, we're going to have 3, 0. Instead of 1, 5 1/2, you'll have 5 1/2, comma 1. And then instead of -1 1/2, you'll have 1/2 -1. Now, you don't have to draw this in. It's not like a requirement, but most people do. The way you can kind of check your work, if you dot in that line y equals x, goes through the origin, has a slope of 1, they should be a reflection. And if it doesn't look like a reflection, then you could be like, oh, whoops, I made a mistake. Do you get what I'm saying? Like, should look like a reflection. All right, now we're going to go back and find the inverse. How do you find an inverse? Switch x and y, good. It would sure help a lot if there was a y in the problem. So what I usually do is scribble out f of x, call it y. Everything else is going to stay put. Just switch the x and the y. So we'll have x equals 5y to the 5th plus 6 over 2. Out of all the homework assignments, this is the one that went the best, like in all my classes. I think it went okay. Switch x and y, and then what you're going to do is get y by itself. So what do we do to both sides? Multiply over the 2, so we'll have 2x equals all the rest of that. I think because it's mainly just solving, and you guys are pretty good with that. All right, then what? Yeah. Subtract 6. And then divide by 5. And then how do you get rid of a 5th power? 5th root. So it is 5th root of all of that. Now, if you write equals y, full credit, okay, because for goodness sake. But we did find an inverse. Does anyone remember what that notation for inverse is? Yeah, it's got that little -1, f -1 of x. Again, I'm not going to take off if you forget to put that, but that's what means inverse. Again, the reason I suggest doing the graph first is when people find the inverse first, they look at this and panic when they have to graph it, which I get. Doesn't this look really scary to draw a graph of? So just graph that one and then flip the points. It's a lot less scary, okay?